So welcome back. We're going to move into Lesson 10. Lesson 10, we're going to revisit the distributive property. The distributive property, a way we can model it is what we call the rectangular model. But remember, the distributive property is just another way we can multiply an expression. So for instance, if I give you 5 times 28, remember what I can do is write this as 5 times the quantity, and I can break 28 apart into a 20 and an 8 if I want to. So the distributive property, what you have is multiplication, and then what's inside the parentheses is some type of addition problem. So that now it can be modeled as the distributive property. A lot of times I can model the distributive property using a rectangular model, where the 5 is this edge, and the 20 and the 8 go along that edge. And then they're like little rectangles, and I can just find the area of these little rectangles by multiplying the edges together. So 5 times 20 would be 100. 5 times 8 would be 40, and therefore I get 140. So I can model that with the distributive property. I can model that with this rectangle, so it's kind of a scratch work. What you're essentially doing, though, is you're essentially multiplying each term by this outside piece. So I'm actually multiplying this 5 to both pieces. So I'm distributing the 5 through both of them. So 5 times 20 would be 100. Plus 5 times 8, which would be 40. 140 plus 100 plus 40 would be then 140. So that's how it kind of looks. So when I do this using the distributive property, what this actually asks me to do is, it wants me to use the rectangular model. Again, I could use the order of operations on this, but we want to do this one just a little bit different. So again, using my rectangular model, what I have is 5, and then I have a 9 and a 7 across this way. We know 5 times 9 is 45, 5 times 7 is 35, and 45 plus 35 would give me 80. Or again, I can come over here and just simply distribute the 5 through the parentheses. 5 times 9, 5 times 7, multiply through the parentheses. 5 times 9 is 45, plus 5 times 7 is 35, and those can combine together to give me 80. Now, looking at this problem, we introduced the algebraic expressions. So we have 6 times the quantity y plus 3. So we have a multiplication problem, but notice that inside the parentheses, we can't actually add those together. Those aren't like terms, so I can't add a y to a 3. What we can do, though, is we can use the distributive property to rewrite the problem. The 6 is the outside edge, the y plus 3 is the top edge. And I can break this apart into 2 small rectangles. I have 6 times y would be just 6 times y. 6 times 3 is the same thing as 18. And those would be my 2 terms. So I have 6y plus 18. 6y and an 18. Those would be my 2 terms. So again, what you're doing is you're distributing the 6 through the parentheses. So 6 times y is 6y, and you have 6 times 3, which is 18. And that's where 6y plus 18 is coming from. And again, that's as far as I can go. You cannot put that expression together any further. The only way I could do anything is if I gave you a value for y, then I could evaluate that expression. But right now, this expression is what we call simplified. It doesn't go any further. Leave that alone. So, my next expression I have is negative 9 times the quantity 6m minus 3. Again, I could use the rectangular model to multiply that out. The negative 9 is one edge, the 6m, and that negative 3. Notice how that negative goes with the term. So I have a 6m and a negative 3. And then I multiply these together. So negative 9 times 6m. Negative 9 times 6 is negative 54. And I just have negative 54 times m. But negative 54 times m, we really can't do anything with that. That just stays put. Negative 9 times negative 3 gives me a positive 27. So those are my 2 terms. A negative 54m, and a 27. And that would be what we refer to as simplified. Don't take that any further. Leave it just like that. Again, what we could do also is just recognize that this 9 has to distribute through the parentheses. So negative 9 times 6m is negative 54m. Negative 9 times negative 3 is a positive 27. So again, if I look at this, to simplify this using the distributive property, I want to use my rectangular model. So I draw my rectangle. The negative 10 is one edge, and I'm multiplying it by this, which is another edge, 7 at a negative 3m. So I partition that off. Negative 10 times 7 is negative 70. Negative 10 times negative 3m is 30m. Negative 10 times negative 3 is 30. 30 times m, we can't do anything with that, so we leave it. So those are about two terms. So I have a negative 70 and a 30m. And again, don't take that any further. That is simplified. I also want to note that you could just multiply the negative 10 to the 7. There's your negative 70. And negative 10 and a negative 3m does give me my 30m. So you don't necessarily have to use the rectangular model, but it's really a good tool to organize if you need it. So we'll do a few more of those. Stay tuned.